So hello everyone, I hope you all are doing great. Before starting the session, just let me know is my audio video fine or not. And after that, we are going to start a very wonderful session for all the mechanical engineers in this formula series, my dear. Very good evening. You just write in the comment section, is all fine or not. Good evening all. So in this formula series, we are going to cover the thermodynamic portion, my dear. All the related formula in this thermodynamic we are going to discuss here. So at least from this topic, this portion must be clear for all of you also, that are you able to recall all the formula or not. So it will be better with writing all the thing on this PPT. You will just continue to write each and every formula on your notes book also. So is all fine? Good evening, Hemang. Good evening. So write fast in the comment section. Can we move forward? Let me check, my dear, is my audio video fine or not? You just make your comment in the comment section. All good? Okay. Yes, Ajay, very good evening. Have you written some mock tests? Yesterday I have just given you some important point, my dear. Have you written some mock tests? At least one or two? Yes, very good. Great. Good. Okay. So because I have told you, you just follow all the point whatever we have discussed last night, and with these all the point when you are going to write the test, my dear, then definitely you will get some benefit. I hope. Yes sir, I follow all the tips, then definitely a little bit benefit you are getting. Day by day it will be improved when you will just continue each and every mock test, my dear. Okay, so let's just start the session. In this portion, my dear, let me tell you very clearly, we are not going to discuss what is the theoretical part, what is the definition, nothing we are going to discuss. We are completely focused on each and every formula, that if it is the question of zeroth law of thermodynamics, this type of question may be asked, this type of numerical may be asked, and formula what exactly you need to apply, this will be the formula. So directly to the point formula we are going to discuss in this portion, my dear. Definitely, and day by day you will definitely feel some improvement. There are 5 to 6 days left for the GATE exam, then definitely every day you will feel some difference. At least 2 or 3 mock tests you need to add in your test list, my dear, for next 5 to 6 days, then definitely the thing will improve. Because let me tell you very clearly, after that, how many days are left? In these days, my dear, you need to do only 2 things. After today, from either Sunday or from the Monday, you can start the procedure, like take the pen and paper, try to rewrite each and every formula. In this session you will continue the same thing with me, but from tomorrow early, from 6 or 7, at what time your day is starting, you just take the pen and paper, and after that you continue to write each and every formula, each and every key point of your subject. After that, if time allow, write the mock test, full length mock test. Just 2 things you need to do for next 5 to 6 days, right? And whenever you are going to write the mock test, you need to follow, you need to check yourself that what mistake I am going to do today, it is going to repeat for the next day or not. It must be decreased. Okay, so 2 things you need to follow from tomorrow. You need not to do so much of thing for next 5 to 6 days. Just rewrite all the formula. When it will be the time of Thursday or Friday, my dear, there must be a condition for you, that you just take a pen and paper and you just recall one particular subject like thermodynamic, and from starting to the last you continue to write each and every formula even without following the proper notes. अगर ये आपकी condition आ गई ना till the Thursday, then you are not going to follow, you are not going to face a single problem in your GATE exam regarding the numerical portion. So let's see how many of you are going to do the same thing. Chaliye start karte hain session. So let's start the session. I hope you will start, you will continue the same thing, my dear. We are not going to stop so much at this place. Yes, one more thing, let me tell you, GATE exam analysis on the same channel, my dear. It will be started on 4th of Feb, just after the exam at 6 PM. So we on the channel, and just I'll I would like to tell one more point, that if you want to share any question, if any question you are able to recall during the exam, you just share with me or any faculty of the mechanical teams. Okay, so let's start the session, my dear. Chaliye. System, surrounding and universe, entire thermodynamic is a deal between these three important points. One is system, second is surrounding, and third one is universe. You know each and everything, what is the meaning of the system, what is the meaning of the surrounding, what is the meaning of the universe. So once any numerical is asked, before solving any particular numerical, fix your point for which part I am going to consider this as a system. Okay, then you will start the question. For example, most of the time it is asked, my dear, find the work done for that particular system. So ask yourself, in this case, system is my gas, system is my piston cylinder arrangement, system is my compressor. What is that particular portion of the system regarding which numerical question is asked to us? Okay. After that, sir, the first question that must come in my mind, that is, what is the ideal gas equation and the different process, my dear. Sir, here you are very well aware for the ideal gas equation, but here I want to make some difference, because in this session, what doubt you are having now, these all the doubt must be clear. Like in this case, I can write that one equation of this PV is equal to MRT, my dear. In this case, this one, this is the ideal gas equation, but let me tell you, my dear, this is valid for a state. It means at any particular state, if the pressure and volume and temperature, anything is given, and out of these 5 parameters, only one parameter is known to us, at state, let me tell you, at state, are you aware with the state? State means system is in stopped condition, either by natural condition or by forcefully condition, my dear. Like if it is a piston cylinder arrangement, and if it is stopped at this condition by some stopper, my dear, then at that time you will apply this equation. Okay. And in this case, my dear, you must know that this pressure must be in kilopascal. Unit is very important. If the pressure is in kilopascal, if you are going to solve the numerical, and volume is in meter cube, my dear, then your R will be equal to, can you please tell me the answer? R must be equal to kilojoule per kg of Kelvin. These all the thing must be clear. And whenever temperature will be multiplied, this must be in the Kelvin. No, in this session, Niyati, we are only going to discuss all the formulas, importance of the units in the formulas. Teju, welcome Teju, aa jao jaldi se. Kelvin, right? And M will be in kg. After that, my dear, there is also one more equation, that is PV. This one is the capital V, and PV is equal to RT. Do you know what is the difference in it? In this case, there is only one difference, that volume is given in meter cube per kg, my dear. Is it clear? After that, similarly for a single state, Sekha Sharma, similarly for a single state, my dear, there is also one more equation, that PV is equal to nRT, and this RT. So sometime in the compressible flow topic, my dear, compressible flow topic, all equations are the ideal gas equation, but in the compressible flow equation, condition, the same ideal gas equation can be used, but in this case, my dear, mass is not given, that is the number of mole, and in this case, R bar will be equal to R bar. It is the universal gas constant, that will be equal to 314 kilojoule per kilomole Kelvin. Yes. Oh, sorry. Unit of P is not kilojoule, it is the kilopascal. Yes, it is the kilopascal. Sorry, my mistake. Yes, Vishal. It's not kilojoule, it's a kilopascal. After that, there is also one more unit, my dear. R, that is specific gas constant, can also be written by R var divided by T. Ajay, this portion, on this particular portion will come back. we'll come back on this particular portion in the topic of real gas equation, because when you write PV is equal to ZRT na, then this will be the real gas equation, not the ideal gas equation. Okay, so it will be equal to R divided by molecular weight. So in this case I can write that R will be the function of molecular weight, my dear, where the capital M is nothing but molecular weight of the body of the ideal gas. Sir, here I want to convey a message to all of you that sometime R, Cp, Cv is not given to us, my dear. You feel this point. Z is the compressibility factor. We are coming on that point. Don't worry. Teju, in the compressible gases, in the real gas equation, this topic will be discussed. You need not to worry in this case. Sir, sometime Cp, Cv and gamma value and R value are not given for any particular numerical. Most of the time you can feel in any type of question. But at that time, my dear, name of the gas will be given. Sir, each and every point try to focus. हर point पे बहुत आसानी से जाओ, बहुत slowly जाओ. You need not to rewrite all the formula within a minute in this session. Here we are going to discuss this formula will be valid, and in this formula we can make this mistake. We have to use this formula in this proper way. These all the things we are going to discuss. Okay, so try to understand each and everything properly. So sometime if the name of the gas is only given, name like helium is given, my dear, so in that condition you will be able to find the value of R. Either it is mentioned in the question or not, you will be able to find the value of Cp, Cv and everything. Either it is given in the question or not, my dear. Like from here we can write, let me change the color of this pen, that Cp similarly I'll write like this, gamma R divided by gamma minus 1. Cv can be written by R divided by, R divided by gamma minus 1. And my dear, in this case gamma can also be written like 1 plus of 2 by degree of freedom of the gas, degree of freedom of the gas. So if you will follow now, then you will get the clear cut idea. Sir, gamma is already known to us. For monoatomic gas, gamma will be 1.67. Diatomic gas, gamma will be, should I write this value? Gamma will be 1.4. Gamma will be 1.67. So it will be for the diatomic gas. It will be monoatomic gas. Monoatomic gas. Okay. And gamma will be 1.33. It will be polyatomic gas. Polyatomic gas. Okay. So in this case, from this entire table, sir, one thing is very clear to us. One thing is very, very clear to us, that if the only name of the gas is given to us, I will be able to find all the thermodynamic property of the gas. Would you say yes or no, my dear? Okay, I'll come on this point. Don't worry. When I'll discuss all the process, my dear, I'll come on this point. Ajay, yes. First of all, you tell me, ideal gas equation in all the form for a state, is it clear to all or not, my dear? Yes or no? This is only the ideal gas equation. Let me tell you, only for a state, not for a process. After that we come to a process, my dear. After that we come to a process, my dear. Good. Very nice. Wonderful, Sekhar. Sir, first of all, on isobaric process, I'll come later. For process, my dear, for any ideal gas process, we can simply write P1 divided by P1 V1 divided by T1 will be equal to P2 V2 divided by T2. Sir, what is the meaning of it? This one is valid for any ideal gas process. Let me tell you, after that, when process are defined, na, ki this is the isobaric, isochoric or something, these are the specific. But if the ideal gas process is going to occur, then P1 V1 divided by P2 V2 or P1 V1 divided by T1 will be equal to P2 V2 divided by T2. Sir, in this case, what exactly you are getting, that if you are going to do a process What is the meaning of this process? You are going to do anything with the system like this. System is changing its equilibrium condition. Whenever you are doing something, आप कुछ भी कर रहे हो, then this ideal gas equation can be written, my dear. This ideal gas equation can be written. After that, let's come to all the thermodynamic process. First is isochoric process. Isochoric process, or it is also known as constant volume process. What you will get the meaning of this isochoric process can be write from here, that V1 divided by T1 will be equal to V2 divided by T2. This pressure will be the constant. Similarly, yes, okay, it's not isobaric. Why you are writing isobaric, all of you? Ajay Gupta? No, it's not isobaric, it's a isochoric. Same thing. So in this case, isochoric means not pressure constant, it is the volume constant. That's why I can simply write that pressure will be constant, that P1 by T1 will be equal to P2 by T2, and this will also be equal to V1 will be equal to V2. Sir, example, what is the example? When your container will be the rigid container. Never it will be mentioned in any particular question that it will be a problem of the constant volume process. Never it will be directly mentioned. Write somewhere in the form of the hint, if the process is isochoric process now, then in that condition, my dear, simple container will be the example of rigid fixed boundary. Boundaries are not going to change. Not like name of the law is also not given. Sarath, name of the law is also not given in this case. Okay, good. After that, after the isochoric process, let's see the next one, isobaric process. Sir, how will you get the idea that what is the example of the isobaric process? Let me tell you, simple, it is the example of piston cylinder arrangement. And piston cylinder arrangement, either heat is provided to the system or heat is rejected from the system. So simply I'll write that P1 will be equal to P2, my dear. In this case, V1 divided by T1 will be equal to V2 divided by T2, my dear. Heat will be added, then volume will increase, and heat will be rejected, then definitely volume will decrease in this case. Kam hoga. It will decrease, my dear. Isothermal process, example. Sir, these words are very important. Quasi-static process or very slow process. Very slow process. These are the indirect hint that this is the example of isothermal process. It is also known as, my dear, hyperbolic process. I can simply write P1 V1 will be equal to P2 V2. That will be the constant. And temperature will be the constant. Then finally, adiabatic heat transfer is 0. T2 by T1 will be equal to P2 by P1. Sir, gamma minus 1 upon gamma V1 by V2 raised to gamma minus 1. Let me tell you, this formula will disturb you lot of time. Sir, if possible, write this formula again and again. Do you know why? Sometimes temperature ratio is given to us. And I think in the thermodynamic, at least once, all of you have done the same mistake. Sometime T2 by T1 is given to us, but when we write P2 by P1, when we write like this P2 by P1, it will be directly written like this, T2 by T1 raised to gamma minus 1 upon gamma. Absolutely wrong. Anyone? Have you done the same mistake? Kabhi na kabhi kiye aisi galti? Focus on this one, my dear. Focus. Most of you, yes, Kanil, very good evening. Most of you have done the same mistake. T2 by T1 is gamma minus, yes sir. Okay, compressible flow, sir. I have done the same mistake. Very good. So during the exam, it should not be repeated. ये repeat नहीं होना चाहिए. Once upon a time, yes sir, I have also done. Yes, so again during the exam, it should not be repeated, my dear. You can just recall the same formula like this, that T2 by T1, it will be equal to Rp raised to gamma minus 1. Temperature cannot be written like RT, or this will be equal to compression ratio raised to gamma minus 1. So it will be better, you can write like this. Okay, yes. Hi Umar, I hope you are doing great. Writing the mock test, polytropic process. Similarly, P2V2 raised to n, my dear, will be equal to P1V1 raised to n, or in this case I can also write that T2 by T1 will be equal to P2 by P1 raised to n minus 1 upon n, and it is also equal to, are you working on the silly mistake, all of you, during the test, during the mock test? Because all the point whatever we are discussed in the last class, definitely it will be helpful when you will focus during the mock test. Yes, after that, sir, these all are the 5 process. Kenil, these all are the 5 process. Naveen, good evening. But after that, there are some important process other than these, that some process are not defined like these 5 process, that isobaric, isochoric, isothermal, adiabatic. This is a very famous question nowadays, my dear, when the process comes out of these 5 process, like piston cylinder arrangement. Yes, piston cylinder arrangement like this, and this piston cylinder arrangement, my dear, is connected with the help of a spring. This is a very famous question, you can feel, yes or no? This is a very famous question you can feel nowadays. So in this case, let me tell you how you will just how will you just solve this type of problem. Sir, first point must be, let me tell you, first property must be, how will you find initial condition? Initial, 3 important condition must be known to us. One is initial condition, means that is P1 V1. Either it is given or it will be a hint indirectly that you will be able to find the value of P1 V1. Second, the final condition. Final condition, that is P2 V2. And third one is, my dear, like relation between pressure and volume. What is the relation between the pressure and volume, my dear? So in this case, let me tell you here, no theoretical point, nothing, my dear. Yes, I am coming on the same point. Yes, Kenil, मैं उसी point पे आ रहा हूं. इन सब कंडीशन में most of the time your presence of mind will work. Little bit concept, moreover presence of mind will work in this case, my dear. Do you know why, sir? Because these types of problem are not fixed on the formula. Because after that, defining this value of the P1 and V1 and P2 and V2, my dear, if you are not able to find the relation between the pressure and volume, that it means your analytical power is just a little bit less. Because in this case, you need to think, sir, if the heat is supply, in this case, if the heat is supply, then definitely if this spring was not there, if the spring was not there, can you please write what was the process at that time? If spring was not there, heat is supply, piston is moving in the upward direction, because this will give you the correct idea when you are having the analysis power with the real life problem. Sir, if the spring is not there, what will be the process at that time? Yes, Kenil say, all of you say, sir, isobaric process, because the piston is applying the same weight. That's why pressure will be the constant. It will be the 100% isobaric process. Vishal, absolutely right answer. Wonderful. After that, But in the real condition, spring is attaching. So when this spring is attached, then definitely it is going to apply one more force, my dear. One more force. And that force is going to increase as spring is compressed. And can you tell me, or are you not aware with this, that spring force is always written like K into X? Yes or no, my dear? K into X. All of you? It means what exactly we all are getting from here, everyone getting from here, that spring force is the linear function of X. Is it or not? Spring force is the linear function of X, my dear. Wonderful. Yes, Kenil. Downward direction I'm talking about. It is a linear function of X. But again, I need not to check the relation between the force and X. No. We all need to find the relation between the pressure and volume. So, are you feeling when this entire piston will move in the upward direction? When this entire piston will move in the upward direction, my dear, can you please tell me cross-section area will be the same or different? Cross-section area will be the same or different? Definitely same. So in this case, if I will divide this Fy cross-section area, if I'll divide this Xy cross-section area, my dear, then I'll get that pressure will be equal to K into X divided by air. Are you not feeling that there is the relation between the P and X? How the X is going to change? We are able to define the relation between the pressure. So can we simply write that pressure is a linear function of X? But again, after that, how volume is changing? Volume is changing, my dear. If I'll multiply by this constant area, cross-section area, if I'll divide by this cross-section area, then K into X will be, so it will be equal to K by A square into volume. Definitely, P is the linear function of volume. So in this case, these all points are nothing fixed. Nothing given that these all points will be fixed. You need to feel that you need to analyze how the properties are going to change in this case. Let me introduce one more problem for you guys, that sometime, my dear, there is also one more question, that there is one person like this. There is one person. So these all are the analytical power I am going to tell you. And this is going to blow a balloon. Blow a balloon, right? This person is going to blow a balloon with a very high pressure. But in this case, my dear, pressure is going to increase directly proportional to the diameter. Pressure inside the balloon is going to increase, that is directly proportional to diameter. But again, when you will solve the same problem with respect to volume, then you get that work done will be the relation between the pressure and volume, not between the pressure and diameter. So what you will do, my dear, can we write like this? Pressure Q will also be equal to diameter cube. And what is the diameter cube, my dear? It is the volume. So from here, can I write that pressure will be directly proportional to the cube root of volume? Is it or not, my dear? Are you able to get this point? So these are the common sense. ये सब common sense के questions हैं. Because this relation is a very important part in basic thermodynamic, my dear, because one question will be asked from the thermodynamic work done, at least one question. And if this one question is related to the formula of 5 important process of thermodynamic, like isobaric, isochoric, thermal, isothermal and polytropic and adiabatic, that is very good. But if it is just out of these 5 processes, you will be in, maximum of the engineers will be in problem. But in each and every problem, my dear, he will give you an indirect hint that pressure and volume are having this relation. Indirect hint he will give you. Like in few problem, it is clearly mentioned that pressure and volume are given in such a way they are making the inclined or the straight line, my dear. It is also one question. A question aaya hai, getting all of you? So yes, you need to read the statement in this basic portion of thermodynamics. Sir, tell me the answer. Is it clear to all? क्या सभी को clear है? Yes, Ajay, your point is absolutely right. Yes, exactly. Your point is absolutely right. But again, in this case, PATM will not be there. It will be KX divided by area plus PATM. Okay. Because already you are just dividing the area with the complete portion. That's why pressure is again divided by area. It's incorrect line. Okay, good, great. Okay, keep sharing the session. Chaliye, after that, representing all the process. Sir, in all these process, in few problem, you may have the doubt between the positive and negative of the work done. So let me tell you, point is very clear. If the volume is going to increase, my dear, okay, if the volume is going to increase, it will be the example of the expansion process. And in the expansion process, can you please tell me what is the work done? Anyone? So in any condition, my dear, if the volume is increasing, that is the 100% example of expansion, then work done will be positive. If the volume is decreasing, on the other hand, my dear, absolutely right, decreasing. Because let me tell you why I am going to write this point. Yes, sir, very good. Why I am going to write this point? Sir, most of the time when we apply the formula, then sometimes we get the wrong answer. Answer is plus, you have written the minus. Answer is minus, but you have written the plus. So one way to check your answer, to verify your answer is this, that what exactly you need to do. If the compression means volume is going to decrease, then at that time it will be the example of the compression, my dear. At that time it will be the example of the compression. Then simply you can say the work done will be the negative. Work done will be negative. After that, any thermodynamic general process you can define like this: PV raised to K is equal to constant. As the value of the K will change, my dear, as the value of the K will change, we are coming on the same point. For the boiler, for the open system, we are coming, don't worry. Yes, Naveen, we are coming. Yes, you are asked, if I'm not wrong, then I think your question is what is the work done for the boiler? 0, right? What is the work done for the work done for the boiler? It will be 0. Reason is very clear. Boiler is the example of an open system, and in the open system, my dear, pressure is not going to change. So in the open system, pressure play a very important role. In these all problem, we are dealing with the closed system first. That is the reason we are clear each and everything with closed system. Okay. So after that, work done, thermodynamic work done, my dear. Thermodynamic work done, sir, write this point. Most important topic for GATE 23. At least one question must be there in basic thermodynamic portion related to this portion. एक क्वेश्चन कम से कम आपका related to work done होना चाहिए in your thermodynamic in 23, my dear. So this topic must be clear to all of you. इस टॉपिक को हर तरफ से, मीन्स आप जहां से चाहो, फ्रॉम वेयर यू वांट टू आस्क द क्वेश्चन, यू फील फ्री टू आस्क द क्वेश्चन. यू मस्ट बी इन कंडीशन दैट वी आर रेडी टू गिव द आंसर फ्रॉम एनीवन. One question must be there from the closed system work done, because this is having the variety of the questions. And again, let me tell you, if the question will be asked from these 5 important process like isothermal, isobaric, isochoric, adiabatic and polytropic, then again it may be the bad luck for you. Do you know why? It may be the bad luck for you. Reason, answer of these type of question are known for all of us, for all the aspirant, not only you. वो आपके लिए नहीं, वो हर किसी को पता होगा. You must expect that question must be there whenever directly it is not given the name of process. It is not given the name of the process. It will be given just a hint to me, that so that only I am able to draw correct PV diagram of this process, and after that I am able to find the area, my dear. फिर वही बात, वही बोल रहा हूं हेमंत, जब भी कभी इन पांचों प्रोसेस से वर्क डन की वैल्यू पूछी जाएगी, मोस्ट ऑफ द टाइम क्वेश्चन विल बी वन ऑफ द इजी क्वेश्चन, माय डियर, वन ऑफ द इजीएस्ट क्वेश्चन. जब भी कभी डायरेक्टली 5 प्रोसेस से पूछा गया, आपकी तो एक्सपेक्टेशन ही होनी चाहिए दैट सर क्वेश्चन मस्ट बी आस्क्ड आउट ऑफ दीज 5 प्रोसेस रिलेटेड टू स्प्रिंग, related to balloon type of question. Piston cylinder arrangement are behaving in such a way that they are not going to follow any of the 5 process other than this one. Yes, good. Yes, exactly. Or in place of ideal gas equation, my dear, real gas equation come into the picture. Wonderful. Real gas equation आ जाए इसमें. That is the reason I am going to discuss that portion, my dear, how you will focus, how you are going to solve this type of problem. Sir, there is only method, only one method that you will get the work done of the closed system, and that method is this one, my dear. Either you believe or you not believe, this is only the method. Sorry. For the closed system, this is the value of the work done, my dear, from 1 to 2, my dear. This can also be written as area of PV diagram. This can also be written as area of the PV diagram is the value of the work done, but it must be taken about volume axis if it is the example of open system. Similarly, BDP from 1 to 2, it is area of the PV diagram, my dear. Area of PV diagram about pressure axis. Pressure axis. Sir, if you are very well aware with this point, most of the time you make the mistake in question of compressor. And in the classroom also, in the marathon also, in few question sessions also, I have seen a very important, very critical problem for maximum of you. Whenever I'll define that this is the work done for open system, this is the work done for closed system, you all write the correct formula. But whenever the name of the open system is given, that compressor is doing the work, pressure is changing from here to here, temperature is changing from here to here, you maximum time make the mistake. You forget to multiply the work done by polytropic index N. Because for the closed system, yes, for the closed system, it is P1 V1 minus P2 V2 divided by N minus 1. But for the open system, it is multiply by N, my dear. So always focus on these words, that compressor, turbine, these are very small thing. Very small thing. आपको लगता है कुछ नहीं होगा इससे, but यकीन मानो जब एग्जामिनेशन हॉल के बाहर निकल के आते हो, at that time you think, I forget to multiply by N. Okay, oh, compressor was the example of open system. I have just written the formula for the closed system. That is P1 V1 minus P2 V2 upon N minus 1. These type of mistake must not be there. Otherwise, again you will start to continue the silly mistakes. Getting my point? Yes, this point. Kanil, right now you are writing. Problem is this. When I will just continue the problem with the compressor name, you will just skip that N. Right now you always writing that P1 V1 minus P2 V2 upon N minus 1 into N. It is okay. But when it is the name of the device will be there, my dear, you forget to write. Again, I am going to force on this word N, and name of the system must be clear to all. So this is the open system or it is the closed system. Are you getting my point? ये open system है या closed system है? Good, 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 good. After that, sir, if you will fix yourself on this point now, that work done for the open system and closed system, it will be the area. Yes, again the same question, Kenil, my dear. If you will use all the formula as it is, whatever you have derived in closed system, whatever you have derived in derivation of the basic thermodynamic. Like if you are going to use all the formula, like in this case I have derived these all the formula, that work done, my dear, just a minute, work done will be equal to area of P into dV. Sir, from here I just want to ask one important thing. एक क्वेश्चन पहले मुझे यहां से पूछने दो. सर, have you completed application of integration to find the area of geometry? Yes or no? Have you studied this portion, application of integration to find the area of geometry? In maths I am talking about. All of you, everyone. Hemang, Ajay, what do you say? Yes, Umar? Yes, yes. Sarath, okay. Most of you have just completed. Very good. Very nice. बहुत अच्छा. Maximum of you have just completed. Do you know one thing? That to find the area of the geometry, there are two things important that is required, my dear. One, what we generally write y into dx. So first important thing, I know what is the initial and final condition of x, so that I can apply the lower and upper limit. And second important condition, my dear, what is the relation of y in the term of x. These two things are required in the thermodynamic also. What you need to think, that work done, any problem of the work done, when you will start to think like this now, that every problem of the work done is nothing else, it is purely the application of integration to find the area. You are not going to make a single mistake in this topic. ये कुछ नहीं है, ये area ही तो find कर रहे हो आप लोग. So one thing you must know, what is the initial and final condition of volume, that is V1 and V2. And second, what is the relation between the pressure and volume. When these two questions will be there in your mind, you are not going to make a single mistake. कोई गलती नहीं हो रही है. Getting? So just you need to focus that work done is nothing but it is the integration of PDV. Once I know the initial and final point of the pressure or volume, and after that if I am able to know what is the relation between the pressure and volume, nothing, not a single mistake I am going to do in this portion, my dear. After that, let me write some points. For the closed system, my dear, isobaric work done can be written like this. For the closed system, isobaric work done can be written like this. After that, let me add few important points. Sir, what are these important points? You know very well that isobaric work done is P V2 minus V1. Sir, if I will write this point, this can also be written like P V2 will be equal to MR T2, my dear, minus of T1. So you must know that isobaric work done, I am having two important formula, not only one formula. One formula is P V2 minus V1, but second formula is also there, that is MR T2 minus T1, my dear. So you must be, second important point, for all these 5 important formula, you must be aware with each and every formula. Means in the term of pressure and volume, you are aware with, and in the term of temperature, you are also aware with. Like this, in this case, we can also write that MR T1 ln V2 by V1, my dear. This is also one more formula. Similarly, this P1 V1 can be written like MR T1 minus of T2 divided by gamma minus 1. Sir, can you please tell me what is R divided by gamma minus 1? What is R divided by gamma minus 1? So don't limit yourself. Never limit yourself. The reason is maximum of you know that polytropic work done. Sorry, this I have written adiabatic. Sorry, just a minute. This I have written adiabatic work. That is not valid for this condition. Sorry. Because we'll make it polytropic work. Here, my dear. MR T1 minus of T2 gamma minus 1 or m CV T1 minus of T2, my dear. So from here, now one important question comes, sir, how will get that P2 minus P1? Someone of you have earlier asked, sir, I think Kenil, it was your question, that sir, P2 minus P1 is the P2, okay, T1 minus T2, yes, sorry. Kenil, you have asked that sir, P1 V1 minus P2 V2 or P2 V2 minus P1 V1, what should I write the answer, my dear? So here I am going to tell you one important point to define the direction, to define the positive or negative parameters, my dear. One thing is very clear, what table you all are going to feel now, what table is given here, my dear. In this table, if you will apply all the formula as it is, then your numerical value will give you the all answer with sign convention also. Are you getting my point? If you will write P1 V1 minus P2 V2 divided by gamma minus 1. So if it will be the example of compressor, then with these all the formula, in compressor answer will directly come with minus sign. You need not to think. If you will follow the formula blindly like this, directly answer will be there. If turbine, positive answer. If compressor, negative answer. But if by mistake, yes, Piyush, yes, bilkul. If by mistake, if you write the formula reverse, like in place of P1 V1, you write the formula P2 V2 minus P1 V1, what exactly will happen in this case, my dear? Just your sign convention may change, your magnitude will be the same. Getting my point? Is it clear? Are you getting my point? It was your question, na? Serious? It was your question or Ajay, I think. Clear hai? So if you will use all formula as it is, then final answer will be there with proper sign. Exact sign के साथ final formula आ जाएगा. Means if it is the turbine, then final answer will be definitely positive. If it is the compressor, final answer will come with negative answer only. But if you will follow the reverse formula, na, then in that condition, what will happen, my dear? Any formula may be there. So I will suggest to all of you, my dear, you can follow the formula like P1 V1 minus P2 V2 or the reverse. It is okay. You focus on one thing: compressor negative, turbine or the expansion positive. So sometime, if by mistake, if you will use the wrong formula, but again, if your concept is clear, there is no issue with the sign convention. Clear? चलिए, let's move forward. Like the session, जल्दी से make it 20 और आगे बढ़ जाते हैं. After that, we are coming on the second important portion, my dear, heat transfer. Here I am going to tell you, yes, very good, Kenneth. Here I am going to tell you what mistake you can make here, my dear. One, I think 2-3 mistakes. Yes, okay. 2-3 mistakes you can do in this type of problem. All of you, in this type of problem, you can make 2-3 mistakes. I am going to clear, I think you just write everything. इन गलतियों को लिखते रहना, कहाँ गलतियां हो रही हैं हम, कहाँ गलतियां कर सकते हैं हम, ठीक है? Okay, sir, one thing. If it is the body maintained at higher temperature and it is the body maintained at lower temperature, that is the TL, my dear. So again, from higher temperature to lower temperature, this value or this heat may transfer, and this how much heat it can be absorbed by the cold body or rejected by the hot body, that amount of the heat can be written by M into C into dt, my dear. Stop at this particular point. Stop at this particular point. Sir, here, this is the basic formula. Sometime, if you feel there are 2 marks advanced level of problem, then in these type of problem, now, C, specific heat, will also be the function of temperature. In any mock test, have you seen this type of problem? यहाँ पे जो C होगा ना, specific heat, this may be the function of temperature. Anyone, my dear? किसी को ऐसा question मिला अभी तक? In the mock test? Yes. So in this case, let me tell you, total heat transfer from, very good, yes. So in this case, my dear, somewhere I have seen, In this case, total heat transfer in any particular body will be the integration of m into C into dt, my dear, and it will be integrated from T1 to T2. Let me tell you, this answer will be heat transfer only mc into T2 minus T1. It can only be written when and only when, my dear, your C is constant. Are you getting my point? C is constant. Is it clear to all? इस point का ध्यान रखना. Maximum time you apply this formula. Okay, good, great. For gas, yes, for gas, Cp generally greater than Cv. After that, yes, after that, Cp is 1.005 kilojoule per kg Kelvin and Cv is 0.718 kilojoule per kg Kelvin. Do you know the mistake? Sir, these two formulas, these two values are only valid for air. In few questions, it is clearly mentioned in the question that it is the example of helium. What we do in helium, we also apply Cp is equal to 1.005 in helium also. Cv is equal to 0.718 in helium also. Don't make this mistake. To calculate the value of Cp, to calculate the value of Cv, we have already written the formula. If the name of the gas is given, then at that time we can derive all the formulas. Okay. After that, zeroth law of thermodynamics, my dear. Zeroth law of thermodynamics say if Ta is equal to Tv, and after that, if Tv is equal to Tc, then Ta, Tv and Tc will be the same. Zeroth law. For this one, the most important part is, most of the time question come that what is the relationship between the different temperature scales, my dear. What you need to follow, you need to write if it is the temperature scale A, if it is the temperature scale B, then all the temperature scale follow the straight line equation. That's all. A into temperature scale B plus of V, where small a and small b are the constant, my dear. AV are the constant. Are you getting my point? Just you need to follow only this condition. At this point, boundary condition are given. At this point, boundary condition are given. Sir, very important point. Even like this, you can feel, sir, Celsius and Kelvin, I want to find the relationship. So again, this is the boundary condition, this is the boundary condition, this is the boundary condition, this is the boundary condition. Two unknown are there and two boundary conditions are there. Apply these two boundary conditions, you will get the answer. Similarly, if Fahrenheit and Rankine is there, then definitely, my dear, two boundary condition and two these unknowns are there. Find the relation. Even any new temperature scale is come into the picture, then definitely what exactly you will do, my dear? Two boundary condition, two unknown, means to drive any temperature scale relation, at least two boundary condition must be given to us, and generally these two boundary conditions are boiling and freezing point. Okay, boiling and freezing point of the water. Let's move forward. First law of thermodynamics, sir. First law of thermodynamics. After that, okay, SS scale may be there. Yes, SS scale may be there. For a closed system undergoing a thermodynamic cycle, total heat transfer will be equal to total work transfer. Sir, here I will also tell you one more mistake. In this question, you make one more mistake. Sir, this is the practical example of, my dear, pedal wheel experiment, if you all are aware with it. Yes or no? This is the example of pedal wheel experiment. Is it or not, my dear? This one. Here I am going to tell you what type of mistake you all are going to do. Maximum of you have done. Let me tell you. This is the weight, my dear. Yes. This is the weight. From here, when the pulley is going to rotate with this weight, and this weight is moving in downward, this fan is rotating, my dear, then this is providing heat to the system, or internal energy is going to increase. So in this case, what exactly value is given, Pankaj? In this case, my dear, normally total number of rotations are given. Like 1000 rotation. For example, 1000 rotations are given. Yes, it is the Joule experiment. And he asked with the example of this work and heat or work and internal energy, he just want to convey the same thing, that sir, how much temperature will be increased after this number of rotation, and if the W or the torque is applied on this member like this 2 Newton meter, my dear. What type of mistake we all guys do in this case? Let me tell you. To calculate the value of the work done, my dear, we write the formula in this case that it is equal to 2 pi n T by 60. I just want to know, is it the right formula or wrong formula, please? When you compare the work done and internal energy in this Joule experiment, these type of questions are also asked. Yes, Teju, very good. 2 pi nt by 60 we do. 2 pi nt by 60 we do. This formula is absolutely wrong, because this type of question you all guys just share in my Telegram channel, or you have just shared to me, and most of the time you write, sir, in the book this explanation is wrong. My dear, in the book explanation is not wrong, because this will give you the unit of kilojoule per second, my dear, because it is RPM. Here RPM is not given. No, here RPM is not given, my dear. Here total number of rotation is given. Total number of rotation. It means it is not going to define per second. It is going to define total value. So this will be the value of the total work done. And that is the major difference. It is even not RPS, Teju. नहीं, ये भी नहीं है. RPS भी नहीं है ये. It's not RPS. It's a simple total number of rotation. Are you getting my point? It is a simple total number of rotation that wheel is going to rotate. You are going to count the number of rotation, and in that 10 minutes you have seen that, sir, in that 10 minutes you have seen that there are 1000 rotation completed by the wheel. That's all. बस इतना part है. And when you will make the difference in your concept now, that sir, thermodynamic deal with total. Thermodynamic का काम ही total से deal करना है. The topic of thermal always deal with total, and HMT deal with theory of machine deal with per second. Flywheel rotating every second. So when you start to think like this now, that when thermodynamic is not going to relate with rate of change, then why we need to calculate the power? We need to calculate total work, because for 10 seconds something has happened. हो चुका है. It is not going to change every second. Getting my point? So focus on this unit part also. Otherwise, my dear friend, most of the time you will be in problem. बहुत सारी चीजें आपको दिक्कत करेंगी. इन सारी चीजों को फिक्स कर लो. If it is the question of the thermal, then it will be related to total. Total means unit of heat will be in kilojoule. Yes. Now the question, very good, very nice. कोई बताएगा? कैनिल ने बहुत अच्छा क्वेश्चन पूछा. सर, if this question is given in the term of RPM, so my dear, let me tell you what exactly he will ask to you. Examiner will ask to you that if the wheel is rotating with the RPM, then every second what will be the value of increment in the temperature? He will ask rate of change of temperature. He will never ask what is the total change of temperature. Are you getting the difference? When rotation is given in the RPM, at that time he is going to ask what is the change of temperature every second. Rate of rotation is given, rate of change of temperature will be asked. Is it clear to all? Clear hua? Canal? So focus on these all the words, because in these 8 to 10 days, what, no, itne to bache bhi nahi, 5 to 6 days, our main focus must be how to reduce the silly mistake even in each and every formula. हर किसी चीज में कैसे कम से कम इसको जीरो पे ले आए. Good. Come back, sir, for the cycle. After that, first law of thermodynamic for a process. Sir, here you need to focus that first law of thermodynamic, that is del Q will be equal to du plus of del W, my dear. This is valid for, tell me the answer, valid for reversible and irreversible process. Sir, there is no direct formula to calculate the value of heat. There is no direct formula to calculate the value of heat in any thermodynamic process. No. After that you start to raise the question, नहीं sir हमने तो बहुत सारे formula किए हैं. But again, let me tell you, this is the only basic formula, my dear. This is the only basic formula in which case you can calculate the value of heat. यहाँ से आप heat find कर सकते हो. If any process is given to us, nothing else is mentioned in the question, then this is the only Raman who is going to help you guys. बस ये अकेला आपको help करेगा. Now you can say नहीं sir ऐसा नहीं है. We have seen a lot of formula like this, that del Q will be equal to du plus of PdV, that is valid for the reversible process. Or we have also seen like this, del Q will be equal to dH minus of BDP. So these are also the formula we have derived number of time. But let me tell you, my dear, yes, I think no, उतना शायद नहीं हो पाएगा. We'll arrange one more session to discuss all the thing of applied portion in detail, my dear. Otherwise आपको 2-3 बज जाएंगे, आधे लोग सोने लगोगे. So enthalpy we have written already. Yes. Okay. So because yes, very good. H will be equal to U plus PV. After that, sir, heat transfer, I am coming on the point. Yes, very good. उड़नी ही चाहिए. अभी भी नींद नहीं उड़ी, इसका मतलब वही है. आप देखो, बहुत सिंपल सा पॉइंट है. आपकी सीरियसनेस बता देती है कि आप कितने ज्यादा तैयारी के लिए रेडी हो. अगर आपकी अभी भी नींद नहीं उड़ रही है, इसका मतलब है कहीं ना कहीं आपने मतलब तैयारी बहुत ज्यादा अच्छी तरह से नहीं की है. हंस रहा है कोई? Okay. Because you know very well, 80,000 of the aspirant has just filled the form of GATE. Near about 50 to 50,000 student of mechanical engineering is going to write the GATE exam. ज़्यादा नहीं रखेंगे, 55 मैक्सिमम 60,000 स्टूडेंट लिखेंगे. उसमें से भी नियर अबाउट 20-30,000 आर द स्टूडेंट वो जस्ट जाएंगे. द कंपटीशन इज हार्डली बिटवीन द 8 to 10,000 ऑफ स्टूडेंट. उनमें से तुम ही हो जिनको रात को नींद नहीं आ रही है, आनी भी नहीं चाहिए. ओके, गुड. बट वन थिंग इज वेरी क्लियर, फॉर नेक्स्ट 5 to 6 days माय डियर, लेट मी टेल यू, अगर किसी की कोई भी ऐसी हैबिट हो दैट you have to take sleep at the time of morning, afternoon, change your timetable, change your entire things my dear. क्योंकि कई बार ऐसा हो जाता है एग्जाम में, जब चीजें नहीं आ रही होती हैं तो एग्जाम टाइम में यकीन मानो नींद आने लगती है, अगर आपकी हैबिट ऐसी नहीं बनी तो, राइट ना. सो if you are having the habit to sleep at 2 or 3 p.m, then you know very well that between 2:30 to 5:30 there is the exam. So there are approximate 5 to 6 days. If you can change your timetable, then plan each and everything in such a way. उससे पहले सोने की ट्राई करो, इवन आफ्टर 5 to 6 PM, उसके बाद सोने की ट्राई करो. बिकॉज जनरली इस टाइम पे नींद आएगी नहीं. इफ यू आर वेरी सीरियस एस्पिरेंट, अगर आपने तैयारी बहुत अच्छे से की है तो आपको यकीन मानो नहीं आएगी नींद. बट ऐसा ना हो कि दोपहर के टाइम, एग्जाम के टाइम पे आपको नींद आने लगे. इस चीजों का, सारी चीजों का ध्यान रखना. कम बैक टू द पॉइंट. ओके, du प्लस ऑफ del W. ओके, कम बैक. बॉटल देख पानी. यस. So, so in this case, the value of the heat transfer for any particular process, my dear friend, any particular process, it is the only formula you can go with. Once you calculate the value of the work transfer now or the work done, then after that heat transfer can be calculated from this formula. You can say, sir, we are having a lot of formula like this. We are having a lot of formula like this. तो सर आप कैसे कर सकते हो कि हमारे पास ये फॉर्मूला नहीं है? सर, दिस इज द फॉर्मूला ऑफ द हीट एडिशन. यस, Cp delta T is the value of the heat transfer for the isobaric process, is the value of the heat transfer for isochoric process. ये लिखा तो है already. So let me tell you, these all formulas are derived, my dear, from this equation. ये सारे formula यहीं से आए हैं. So you must know this formula is only the Rampart for all the problem related to heat transfer, my dear. Related to heat transfer. Sir, here the value of the work done for the closed system is given to us. If I'll write the value of the work done for open system, my dear, then it can be written constant pressure process, work done will be 0. If I'll write constant volume process, work done will be minus of V P2 minus of P1, my dear. Okay. After that, okay. After that, if I'll write the work done for the open system, similarly, I'll write constant. So this will also be the same process, my dear. This is the only process where the work done of open system and the work done of closed system will be the same. After that, reversible adiabatic process, work done can be written by gamma minus 1 into P1 V1 minus of P2 V2. These all table. Polytropic work done for the open system. Polytropic, my dear. Yes, Pavlu, good evening. You are very late, yaar. This will be written by N upon N minus 1 P1 V1 minus of P2 V2. Sir, I just want to know one thing. Can you please tell me, कितने लोगों को ये पूरी टेबल याद है? How many of you are very well aware in this with this entire table, my dear? How many of you are very well aware with this entire table? Very nice. Wonderful. Nice. Great. So if this table is clear to you now, sir, there are few words you write with very highlighted pen. Open, close. Open, close. Let me tell you why, sir. Because most of the time, okay, very nice, Teju. Most of the time, sir, you make the difference from here. But whenever during the exam, during the mock test, the system like open and close will be there. Then at that time, you are not able to make the difference. You just forget sometime this N. You just apply sometime this N. This type of mistake should not be there in the mock test, should not be there in the exam. How will you make the difference? और ये ऐसा नहीं कि आपको याद नहीं है, इन्हीं को silly mistake बोलते हो. These are the silly mistake you have to reduce. You have to make it 0. If 0 is not possible, then near to 0. एक आध होती है, चलता है, लेकिन पता चले 10 ना हो जाए. So these are the thing on which you have to control. और कैसे करोगे? When you will take a small pause during the solution of the question. Read the entire question. Ask us all the possibility. It is the open system, closed system. It is the reversible process, irreversible process. It is the equation of temperature I am going to apply, equation of volume I am going to apply. Ask all the possibility first, then you touch the question, my dear. Good. Then, steady flow energy equation, SFEE. That can be written, mass flow rate at inlet will be equal to mass flow rate at outlet. Similarly, conservation of energy, H1 plus of MC1 square, my dear, plus of mgz1, it will be also equal to Q, plus of Q, it will be also equal to H2 plus of, my dear, 1 by 2 mC2 square plus of mgz2 and plus of W of control volume. Okay, W of control volume. Yes, sir, this problem, if the question will come from here, then this type of problem may be very easy for you, related to turbine, related to compressor, related to any open system. This type of problem may be very easy, SFEE. But my dear, problem will be more difficult if the question will be asked from USFEE. Yes, either diffuser is there, nozzle is there, you are not going to make any mistake in this case, because my dear, nozzle and diffuser, these are nothing but, nozzle and diffuser is just a special case of this equation. But most of the time you feel the problem in this type of question, like unsteady state problem, unsteady state problem, when something is filling or something is going to empty, my dear, empty. In these type of problem you are going to make very much problem, face lot of problem in this case. Sir, first of all, 2-3 things you must know. Conservation law of mass says that rate of change of mass in the control volume, it is known as mass flow rate at inlet minus of mass flow rate at outlet. Sir, एक और मैं यहाँ पे पॉइंट बताता हूँ. Sir, these equation can help you only. Yeah, I'm coming on the same point, Kanil. I'm just coming on the same point. Don't worry. These equation can be written in the original form, but after that, my dear, your smartness work a lot in this case, because after that you know very well, in this case you are not able to get the answer. You have to do the integrate. Are you getting my point? Either it is the filling the tank, it is the empty the tank, or it is the partial filling the tank. Means tank is already filled and you are going to again fill the tank, or it is the partial emptying the tank, my dear. So these all questions will depend upon the presence of mind, with your smartness, how you are very well aware with the topic of integration. Because generally most of the time, my dear, let me clear this point. Most of the time when after this equation I will write the integration now, that like m2 minus of m1 in the control volume. So most of the engineer ask, sir, what is the difference of this dm and this m2 minus m1 of the control volume? Both are the same thing. Once you have written dm over dt, that is the change of mass, and second you are going to write m2 minus m1. My dear, both things are different. This m2 minus m1 is coming after the integration. What is the meaning of it? After the integration, this value is coming. So this value is going to tell you when process was started, the mass was m1. When process was completed, the mass become m2. So sir, what is the meaning of this dm over dt? Sir, this one is the rate of change of mass every second. Means you can assume that this problem is just that differential equation for what you have to solve. You have to integrate and you find the total change, my dear. Do you know in the integration you apply the lower limit and upper limit? So first of all you find that derivative. So this is just a derivative. My dear, this is going to tell you that what is the rate of change of mass every second. And when I will integrate it from m1 to n2, then it will give you the idea that what was the mass before starting the process, Kanil, and what is this mass after completion the process. Because let me tell you, and again I'll just repeat the same thing. You guys tell me that, sir, thermodynamic deal with total or rate, it deal with total. So this is going to tell you rate, and you are making this rate into total. What is the total change of mass in that duration? A little bit point is clear. Even I'll give you 1 to 2 problems related to this topic. Either I'll share in my Telegram channel or I may have one session for that. Don't worry. Okay. एक दो तीन प्रॉब्लम है इससे रिलेटेड मैं आपको शेयर कर सकता हूं, बट वन पॉइंट इज दिस, आर यू गेटिंग द डिफरेंस बिटवीन dm over dt and m2 minus m1? One is the rate of change of mass every second, and second is total change of mass. And in the thermodynamic we deal with total, not rate of change of mass, my dear. Getting? Okay. Similarly, in this case, what is the total change of energy in the control volume? It will be the mass flow rate HI minus ME HE plus of heat transfer rate minus of work transfer rate. Again, you need to understand in this case, sir, what is the meaning of this? Again, this topic is going to tell you, that rate of change of internal energy in the control volume is something like this. So this will never be the answer, my dear. नहीं, ये आंसर नहीं होता. It is just a starting. ये तो शुरुआत है. After that you will integrate and you write total change of internal energy. Means here the rate of change of internal energy is given, but you need to find total change of energy. So what you will do? You will do the integration. And for that integration, condition will be given to you. Yes, in any case, if this exit mass becomes 0, this work done becomes 0, this heat transfer becomes 0, these three conditions are there, my dear. Again listen, exit mass 0, okay, heat transfer rate 0, and work done is 0. In that condition, this U2 will be equal to HI, or this final temperature will be equal to, my dear, gamma of initial temperature. This is the difference. This one is the difference. From here, yes, from here, let me give you one more idea, my dear. एक और मुझे यहाँ पे shortcut बताने दो. If nothing, not a single form of the energy is going to store, is going to added or rejected from the system, and if any fuel or any flow is there with the enthalpy of H, my dear, nothing is added, nothing is subtracted. This air is going to flow with the enthalpy of air. When this will be stored into the closed container, at that time, my dear, this total enthalpy will be converted into the internal energy. That's all. Flowing working medium is directly stored into the stopped working medium. Stopped means from the pipeline you are filling the system or working medium into a container. Then enthalpy of the motion become the internal energy when fluid or the working medium is stopped, my dear. Okay, working medium is stopped. This is also right. Yes, exactly. Sir, if the already gas is filled now, then with Tg, then final temperature will be equal to Tg plus gamma Ti divided by 2, my dear. Is it? But there are definitely 3-4 conditions. One, total mass of the gas must be the same as the mass is entering into the system. One important thing. Second, both gas must have same properties. Third thing, no rejection or addition of heat is there. Getting my point? And last thing, not a single boundary of the container is flexible. These all conditions. So this thing I am going to tell you that, sir, when you are going to recall any result, कोई भी एक result याद रखते हो ना, then for that result, my dear, you know all the boundary condition, you know all the assumption. In the last year question paper, 90% of engineer has made a single mistake, very critical mistake, my dear. और वो mistake ये थी, everyone has just recalled the formula that final temperature is equal to gamma into Ti. But they forget to check the assumption whatever we have made during the during that solution. Heat rejection must be 0. Teju, your point is valid, but you know the assumption. Getting my point? You know the assumption, na? Answer is absolutely right. Your answer is not bad. It is absolutely right. But you must know all the thing, my dear. Yes. Otherwise, it will be better. Yes. Otherwise, it will be better that from this condition, you start your integration, you start your question. So either you just recall all the numerical formulas with the proper assumption, whatever you have made, what else you can do, you just follow all the steps to do the integration. Okay, after that, sir. Second law of thermodynamic and entropy. Let me tell you, at least one more question, my dear, at least one question you can just expect from this topic. Either Clausius inequality law or entropy, sir. In this case, efficiency of heat engine will be equal to 1 minus T2 by T1. It will be equal to 1 minus Q2 by Q1. And in this case, my dear, we can write efficiency of actual heat engine, that will be equal to Q2 divided by Q1. This one is only valid for actual cycle or the actual engine, my dear. This one is valid for reversible heat engine. Is it? Reversible heat engine. And these all formulas are valid. All formulas are valid for source and sink. It cannot be valid when everything is going to, or all temperature are going to change, my dear. Similarly, if I'll write the refrigerator, then COP of refrigerator can be written by T2 divided by T1 minus of T2. It will be also equal to Q2 divided by Q1 minus of Q2. After that, for the actual refrigerator, we can write, my dear, that is for actual refrigerator or the industrial refrigerator, and this one is for, tell me the answer, this one is for only reversible refrigerator. Reversible refrigerator. Similarly, if I write for the heat pump, T1 divided by T1 minus of T2, it will be also equal to Q1 divided by Q1 minus of Q2, or COP of the heat pump that will be for actual, that will be for reversible only. And after that, we can write COP of the heat pump will be equal to 1 of efficiency, will also be equal to, I think ये तो सभी को याद होंगे, that is the reason I am not going to discuss these all the point in detail, ये सभी को याद होंगे. उसके बाद कुछ important point है जो आपको पता होना चाहिए, like if two reversible heat engine are working in series, my dear, series, if two reversible heat engine, these are the important points. ये शायद आपको याद हो, it is well and good, नहीं हो यहाँ पे रट लेना. Two reversible heat engine are working in series, my dear, then if they are having the same efficiency, like N1 is equal to N2, then in that condition, intermediate temperature must be equal to T1, T2. Is it clear to all? ये याद है सभी को? तेजू, Kenil? If the efficiency of two reversible heat engine will be like this, even if the work output of two reversible heat engine, that W1 will be equal to W2, my dear, then intermediate temperature will be equal to how much? T1 plus of T3 divided by 2. And similarly, in that case, overall efficiency we can write N1 plus of N2 minus N1 N2, my dear. So these are also the important formulas. Generally, most of the student can skip these all the portions अगर यहाँ से क्वेश्चन आए, but definitely you are not going to skip for these all the questions. ये सब क्वेश्चन आपसे नहीं छूटने चाहिए, because ये फॉर्मूला सभी को याद होते हैं, and you must expect that question should not be there from these topics, these two formulas. ये तो सबको याद हो जाते हैं. It's not a big deal. After that, very important point, if heat engine, refrigerator or heat pump, any system is working under the multiple reservoir, my dear, multiple source or multiple sink, that question will be solved only from Clausius inequality law. Are you getting my point? All of you, that question will be solved, my dear, only from the Clausius inequality law. If the reservoir are more than 2, दो से ज्यादा है, and all are the infinite reservoir, let me tell you, all are the infinite reservoir, my dear. Kanil, Sanket, listen, try to listen this point. All are the infinite reservoir, then that will be solved with the help of Clausius inequality law. But all are the finite reservoir. If a heat engine, heat pump, refrigerator working all the on the different reservoir, and all reservoir are infinite, they will be solved with the help of Clausius inequality law. But if all are the finite reservoir, can you please tell me the answer? अगर सारे finite हुए, then these problem will be solved. Finite means T1, T2, T3, T4, all temperature are changing, or any of these temperature is changing. Please tell me the answer. Anyone? If all are the infinite, they will be solved by Clausius inequality law. All are the finite. Teju, I want to listen from your side. Refrigerator, or heat pump or engine. If all are the reservoir which are having the infinite source or sink, that will be solved by Clausius inequality law. If all are the finite or any of that is the finite, that will be solved by it, my dear. Nahi aa raha? That question will be solved, no Kenil, that question will be solved with the concept of entropy change of universe. Not at all. No. That yes, point is absolutely right, Teju. You directly reach on the answer. अब तो सीधे आंसर पे पहुंच गया, that geometrical mean of all. Yes, but how this answer is coming? Because otherwise again you will just focus on the result, you forget the procedure. So when a heat engine, a refrigerator, a pump is working between number of source or sink, my dear, if it is the question related to infinite source, that will be solved by Clausius inequality law. And if it is working on the finite source or sink, that will be solved by entropy change of entire universe in a cycle must be 0. Point clear हो गया है? Is this point clear? Sanket, Teju, Kenil, Ajay, is this point clear, my dear? Good. Great. After that, entropy. Entropy is the degree of molecular randomness existing in the system. Higher is the randomness, higher will be the entropy. Sir, for the reversible process, the general formula of entropy change can be written like this, and for the irreversible process, general formula of the entropy can be written like this. I will add one more point here. Yes, Sarath. That will be always positive, my dear. Sir, here these are the very general points we have discussed a lot of time, when entropy will increase, when entropy will decrease, when entropy will be constant. But from here, let's discuss how will you find the total change of entropy for the process, my dear. Total change of the entropy for this process But before that, let's write combine first and second law of thermodynamics. That TdS is equal to du plus of PdV, that is the first combined law, and TdS is equal to dH minus of VdP, that is the second combined law. After that, what is the total change of entropy, my dear? We can simply find the change of entropy. Sir, this question, this portion, I have discussed a lot of time earlier also. Today, I am also going to discuss the total change of entropy. I just want to know, is this table formula, how many formula are involved in this table? Is this table clear to everyone? हर एक को ये टेबल याद है, क्या होता था, कैसे आंसर आता था, कितना आंसर आता था? Is this table clear to everyone, my dear? कुछ याद आ रहा है? थोड़ा बहुत धुंधला धुंधला. I have discussed this table lot of time because maximum number of students feel the problem that when and where I need to apply what formula. अब ये बहुत गलत है थोड़ा थोड़ा. देखो, total change of entropy, whenever I am talking about the universe, he may ask that what is the change of entropy of the system or what is the change of entropy of the surrounding. Sir, in this system, yes, okay, don't worry. In this system, my dear, okay, don't worry. In this system, either I can fill the finite body, means either I can fill the solid, I can fill the liquid. That will be the example of finite body. That is either liquid, my dear, or solid, my dear, or in this case, either I can fill the ideal gas. So for the system, I can have the two variety of formula. One formula for the finite body and second formula for an ideal gas. So whenever entropy change of system is asked, I need to check what is the formula for the finite body. Finite body means this is the solid, temperature is changing from Ti to T final. What is the change of entropy of the finite body? Like this. Can we write like this? For the finite body, mCp ln T2 by T1 or T final by T1. If it is the finite body, means if it is the case of liquid or solid where the temperature is going to change, you will apply the formula. This one is only the formula. Clear hai? Clear to all of you? After that, in the system, there is only one more portion that is left, my dear. What is that one? That one is your Ajay, is it or not? That one is ideal gas. So for the ideal gas, my dear, I am having three important formula. We can apply any formula out of these three. इन तीनों में से कोई भी फॉर्मूला अप्लाई कर सकते हो. हाँ, एक पॉइंट और आया अजय का. सर Cp और Cv any can be applied, my dear. In case of liquid and solid, there are no value of Cp and Cv. Both are the same value. Getting my point, Ajay? In case of liquid and gas, my dear, there is no. We are coming on the same point. Don't worry. Sanket, I am coming on the same point. Don't worry about this. Yes. Clear? Okay. Sanket. Good. After that, sir, from only these two formulas, one for finite body and second for any of this group. कोई भी एक formula याद कर लो, कोई भी एक formula उठा लो, तीनों के तीनों याद कर लोगे, well and good. From these two formula category, one for the finite, second for the ideal gas, are you able to find entropy change for an system or not, my dear? Entropy change for an system, are you able to find or not? Yes. After that, what is the next question? Next question is, how will you find the entropy change of the source? How will you find entropy change of the source? Heat is rejecting from the source. Means you can say source or you can say any body in which temperature is not changing, that entropy change of the source can be written by, my dear, anything when temperature is not changing, it can be written by Q1 divided by T1. Do you know why it is Q1, my dear? Q1 means heat is rejecting, T1 means temperature. Even it is not valid only for the sink or source, it may be valid everywhere when temperature is not going to change. Jab change now. Like sometime in one problem you have seen like this. There are two walls which are maintained at 1000 Kelvin and 300 Kelvin, my dear. And the heat is going to transfer from here to here. Any one of you have seen this type of question? Yes. What is the change of entropy in this case? So one boundary, temperature is not changing. Second boundary, temperature is not changing. If the temperature is not changing, directly apply heat divided by temperature is the answer. That's all. Directly apply the formula, heat divided by temperature is the answer, like this. From where heat is rejecting, you will be writing with minus sign. From where to where heat is reaching, you are writing with positive sign. That's all. Similarly, what is the entropy change of sink, my dear? Sink means heat is supplied to that system. That I'll write that change of entropy of the sink, my dear. Sink means heat is supplied. Anywhere when temperature is not going to change, you can blindly write the formula like this. T2. After that, in the mixing of two gases, two fluid, what will be the final temperature? Final temperature can be written like this: M1C1T1 plus of M2C2C2, and change of temperature of the entropy of the universe, change of entropy of universe can be written like this. I think someone of you have asked a very important question. Sir, how the entropy generation is calculated? My dear, there is a very important point, that what is the change of entropy of universe? I think someone of you have asked. Can I write change of entropy of universe will be equal to system plus of surrounding, my dear? Is it or not? आप में से किसी ने पूछा था शायद. Yes. Kenil, this type of question we have discussed earlier. When a aluminium ball from 200 degrees centigrade is drop into the water, this type of question we have solved, my dear. Right? So, if you are able to find the change of entropy of universe, that system may have the finite or the ideal gas. Surrounding may have the source or sink, my dear. So this is the total change of entropy. And how this total change of entropy coming, my dear? Just because of entropy generation. Just because of entropy generation. Have you got the answer? Total change of entropy is itself the entropy generation, my dear. पता नहीं किसका आंसर था, क्या संकेत आपका था? Have you got the answer? Total change of entropy of the universe is the entropy generation itself. Is this point clear? कुछ तो बोलो. Clear है? Good. After that, sir, entropy change in the solid and liquid and gas. Solid entropy change is minimum, liquid intermediate, and ideal gas it will be maximum. Third law of thermodynamic, entropy of a perfect crystalline body as the absolute zero temperature is zero. Theoretical point is there. Yes. After that, available energy, my dear. Available energy. This available energy can be written like Q1 1 minus T0 divided by T1, my dear. Or it can also be write 1 minus T0 into ds of the system. Sorry, I have written by mistake. Q1. From here we can simply write okay, yeah, sure. Either you can share on my Telegram channel. I'll explain, don't worry. In this case, my dear, unavailable energy will be equal to T0 ds of the system. Sir, on this part you need to focus. Take a pause at this particular portion, my dear. Sir, whenever you calculate available energy, then available energy is change in the entropy of system, not overall change. For example, sir, like this. For example, somewhere like this. This is the system. This one is the system. When in this system, my dear, when the heat, then definitely entropy will increase. Is it or not, my dear? When heat will be supplied to the system, just a minute, when heat will be supplied to the system, then definitely entropy will increase. So in this case, from 1 to 2 now, entropy is going to increase like this. Entropy is going to increase. So when this is an aluminum ball like this, so if you are going to supply the heat to this aluminum ball or rejecting the heat to this aluminum ball, so in this case, if you want to check the available energy for this ball now, then you need to ask two important things. One thing, sir, what is the amount of heat transferred to the system? And second thing, my dear, what is the change of entropy of this aluminum ball during the supply of heat or the rejection of heat? दो पॉइंट पे हम कभी नहीं जाते. What exactly we do? We write only single formula, that Q1 1 minus T0 divided by T1. It is the formula. No, my dear, this is just a formula of a very simple level of problem like Carnot cycle. ये बहुत आसान formula है. So in this case, you need to focus. Available energy of any system will be purely dependent upon the entropy change of that system when it is occurred during the addition or subtraction of the heat from that system. Getting my point? कुछ थोड़ा बहुत याद आया है? बनना इसका point? Available energy is the critical point for maximum of you. You need to focus on two important points. If it is any thermodynamic system, what amount of heat will be supplied or rejected from the system? दोनों ही केस में, either supply or rejected from the system, I need to calculate that heat transfer. One thing. Second, during this condition, I will check what is the change of entropy of that system. No, Amata Singh. Irreversibility पे आ ही नहीं जा रहा है. मैं यहाँ पे आपको मेन डिफरेंस बता रहा हूँ. What is the difference? What is the mistake we all do, my dear, between the available energy and irreversibility? I am coming on the same point. Between the irreversibility and available energy, what maximum of us make the difference? I am coming on the same point. Sir, in the available energy, it is the change of entropy of the system. And let me tell you, this entropy of that system will change even the process is reversible. Sir, अगर reversible होगा और heat transfer system से होती है, if the heat is transferred from the system, my dear, then definitely there must be the change in the entropy of the system. तब भी entropy का change होगा. Are you getting my point? This is not the change of entropy due to irreversibility. No. This is the change of entropy either due to addition or due to subtraction of the heat. Even the process is reversible. And this is the change of entropy of system only, not the entire universe. Is it clear? In available energy, what change of entropy is coming, my dear? कुछ हो रहा है clear? In available energy, what change of entropy is coming, my dear? Is it clear to everyone? Teju, Ajay, Sarath, Kenil, Males, are you there? Yes. Yes. In the availability, I'll explain that point. First of all, just give me this point, my dear. In this case, no part. In this case, it is not rejecting. It is the gaining of heat. It is the gaining of heat. Let me tell you why, Ajay. Because in this case, my dear, entropy is increasing. Means you are going to, system is absorbing some heat and that is doing some mechanical work. Getting my point? Is it clear, Parth? Your doubt clear now? Whenever entropy will increase, then heat will be supplied to the system. My dear, temperature may decrease. It is possible. Even during the heat supply, temperature may be lower, may be decreased. It is possible. Temperature may be constant. Most of the time, I have told to you, temperature is not going to define the heat directly. Temperature can be increased, can be decreased during the heat supply. Entropy is the thing that will define the heat supply. If entropy increasing, heat supply; entropy decreasing, heat rejection. Process is reversible then. Yes, entropy exactly Ajay. Second, availability. So availability function, it is W useful, my dear. It will be equal to phi 1 minus of phi 2, and generally phi can be written U plus of P0V minus of T0O. And for the open system, it will be equal to H minus T0S, my dear. T0S, okay. After that, irreversibility, I. That is the difference between the maximum work minus of actual work. Someone of your friend was asking a little point that, sir, what is the difference between the maximum work and actual work? This is the difference, my dear. Whatever you have calculated till now, Ajruddin, that was the maximum work. Availability is the maximum work. But in the actual work, actual condition, my dear, that work is not possible. So how that work will go, my dear? That work will go into the irreversibility. So irreversibility between will be this one, and this will be somewhere like this. And let me tell you here that in this case, my dear, it is not the change of entropy of the system, that is the change of entropy of universe. So this will be only there, yes, sir. This will be only there when the process will be irreversible. Are you getting my point? When the process is irreversible, then and only then your entropy generation will be there, my dear. Then and only then your entropy generation will be there. If no entropy generation, no reversible process, irreversibility will be zero, my dear. Irreversibility, in that case, it will be zero. Is it clear to all? So are you feeling in the irreversibility, you are going to check the entropy change of universe, but in the in the available energy, you are going to check the entropy change of system only. Getting? Entropy change of system only you are going to get. Okay. Yes. Okay, Canyon. Good. After that, sir, in this point, I'm not going to explain in this case so much of thing. I will suggest only one thing. I have written all the formulas. सारे फॉर्मूला लिखे हुए हैं. Don't go to the exam without recall these all the formulas. सारे formulas, whatever we have written, these are the Maxwell equation. Because it's not a time for you, my dear, that I will give you number of shortcuts, number of things to recall these all the formula. It will be better what formula you are going to follow, what formula you are going to use, what method you are going to use to recall all the, then follow these all the things. उन्हीं को follow करो, right? Yes, very nice. Okay, good. ये तो देखा देखा लग रहा है. नहीं देखा देखा लगेगा ही. But in this point, let me tell you, these all formulas look very similar. सब एक जैसे लगते हैं. So don't forget to clear these all the point which is coming with plus sign, which is the minus sign, which is positive, which is negative. Each and everything must be clear. After that, my dear, second, if you don't recall this formula, it is okay. इसको छोड़ दो, इसकी जरूरत नहीं पड़ेगी. But don't forget to write internal energy formula. Reason, let me tell you now. Nowadays, Tomato Singh, Teju and Kenil, question may be asked, definitely must be asked, not from the ideal gas equation, from the van der Waals equation. What he will do, he will give you van der Waals equation like this: P plus AYV square or V minus of V is equal to RT, my dear. Yes, yes. Or similarly, just a minute, Kenil. Or it may be simple like this. This one is also the van der Waals equation with some modification, means he have not written the molecular effect, my dear. Molecular effect. These are the very famous question of ESE exam. And definitely nowadays questions are used to ask from ESE exam if the subject is thermodynamic, my dear. So what he will do, find the change of internal energy or enthalpy, just a minute, or enthalpy by following the van der Waals equation. ऐसे क्वेश्चन आते हैं, तो उस टाइम पे आप क्या करोगे? फॉर एग्जाम्पल इफ दिस क्वेश्चन इज गिवन टू अस, मैंने 2-3 क्वेश्चन इस तरह के बहुत बार कराए हैं आपको इस यूट्यूब सेशन में. दिस क्वेश्चन इज देयर, माय डियर. सो इन दिस केस व्हाट यू विल डू, you will convert your pressure in the term of volume or the temperature, and then you will do the differentiate, then you substitute all the value, then you will get the change of internal energy. बहुत इंपॉर्टेंट क्वेश्चन हैं ये सब, भूल मत जाना इनको. Okay, yeah. Significance of A and B, my dear. B is the consideration of the size of the molecule, and A is the consideration of the intermolecular force. Okay, so A is coming due to the intermolecular force, where the V is coming due to the size of the molecule. That is already assumed as a neglected, but in actual condition it is not neglected. So again, you are not allowed to forget these formulas, my dear. One is HP. Similarly, from HP, one more formula is yet to come. Yes, one more formula is yet to come. Sorry, this is again, sir, from thermodynamic question. If a single question will come, my dear, a single question will come, that will be the numerical. So let me tell you, my dear, question will be there related to the actual gas equation, and after that he will allow you to do the differentiation. पर कब differentiation कर पाओगे? Whenever these type of formula will be very clear to known to you. Near about 8 formulas are there. 8 formula है. बहुत बार मैं आपको बताया हूं कि इनको बिना याद किए हुए मत चले जाना. Again I am going to tell you, इन सारे formula को याद करना. Okay, after that, coefficient of volume expansion, isothermal compressibility, and Cp minus Cv is also written as question might be asked from this portion. Yes, question might be asked from this portion, that Tv beta square upon Kt, where this question may be given that beta is this one, Kt is this one, isothermal compressibility factor is this one, and volume expansion coefficient is this one. At this volume and this temperature, find the value of Cp minus Cv. Find the value of Cp minus of Cv. So most of the question answer you can find from these formulas if it is known to us. मेयर इक्वेशन ये नहीं है, वो बाद में इसको आइडियल गैस बनाते हो ना, तो जाके वो मेयर इक्वेशन बनती है. वी हैव ऑलरेडी रिटन. सर, आई वाज टॉकिंग अबाउट दिस, that Joule-Thomson coefficient will be the relation of temperature and pressure. No, not always. Again, Kenil, whatever you have written, these all terms are valid for the ideal gas. What exactly I am going to tell you, now the question will be a little bit twisted in 23, my dear. Then definitely he will first allow you to do the integration. Getting my point? पहले इंटीग्रेट करो उसको, देन यू गेट द आंसर. दैट इज द रीजन, माय डियर. हियर जो आपको चीजें याद है वो तो मैं डिस्कस ही नहीं किया बिल्कुल भी. आई नो वेरी वेल दैट फॉर एन आइडियल गैस Joule-Thomson coefficient is 0. That's why I'm not going to discuss that portion. When Joule-Thomson coefficient will be positive, it will be a cooling. Joule-Thomson coefficient will be negative, it will be a heating. I'm not going to discuss these all the portion. मैं कह रहा हूं यहाँ पे numerical अगर आया तो कहां से आएगा? Are you getting my point? Yes, this may be the numerical. This may be the numerical, my dear. From here, this will be the numerical. जो सारी चीजें आपको याद हैं, and you are feeling, sir, in this post we are master, वी नो ईच एंड एवरीथिंग, आई विल प्ले एट दैट पॉइंट माय डियर। बोले कोई फायदा नहीं है याद का, वो मैं पूछ ही नहीं रहा हूं, वहां से तो अपने क्वेश्चन स्टार्ट हो रहे, फ्रॉम दैट पॉइंट वी आर स्टार्टिंग द क्वेश्चन, वो सारे याद हैं, देन यू आर एलिजिबल टू सिट इन द एग्जाम। यस, सो sir, this may be the question that pressure V minus of V is equal to RT. For this gas, find the Joule-Thomson coefficient. This type of question may be asked. One more question, my dear. Pressure is making, or pressure is related to this. Pressure is the function of temperature. With this, pressure is also the function of volume. Then find the Joule-Thomson coefficient for this value. ऐसे ऐसे क्वेश्चन आ सकते हैं, लगाओ, कहां से लगाओगे दिमाग? Are you getting my point? These type of questions may be asked. Okay, these type of questions may be asked. Getting my point? Because even if this P and this P is also given in the question, until unless you are not aware with this formula, how can you apply this formula? How can you get the Joule-Thomson coefficient? कुछ भी याद कर लो. Joule-Thomson coefficient is positive, answer will be cooling. Joule-Thomson coefficient is negative, answer will be heating. याद करते रहो, वो खेल गया आपकी जिंदगी के साथ, हो गए बर्बाद. Are you getting my point? You know each and everything, but यहीं पे खेल गया. Clausius-Clapeyron equation. Clausius-Clapeyron equation. Clausius equation. Clapeyron equation. Yes, okay, good. After that, there may be the Clausius-Clapeyron equation like this. Okay, one more thing. In this case, my dear Venu, one more thing. Sir, again, let me tell you, you all are aware with this PT over PT, dP over dt in isentropic process like this or like this. Clausius-Clapeyron equation and Clapeyron equation both are known to us. Kenil. After that, the same question examiner may ask, find the slope of PT diagram at triple point. This is the question for you. In these type of language, he can play with your feelings. In these types of way, my dear, he can play with your feelings. Now, अब आपको ये तो पता है कि सर Joule-Thomson coefficient, the formula of the Joule-Thomson coefficient is written like this, but you don't know that Joule-Thomson is going to tell you. Yes, देखो पता है ना उसने, the same type of question सर मिला था. Yes, good. Tomato Singh, Joule-Thomson coefficient is nothing but it is the slope of PT diagram on which you draw the triple point diagram. अरे जिस पे आपको पता नहीं इस प्रॉब्लम का, ये जो आपका Joule-Thomson coefficient था, it was going to give you the slope of this diagram. Are you not able to feel that this was P, my dear, and this was T? Why you are not feeling? These all three lines are drawn on PT diagram. तो Joule-Thomson coefficient ने इसका slope ही तो बताया था. Why you are not feeling? यहां खेलेगा वो. So here at this point, triple point temperature value is given and all other value are given. So this is nothing but, my dear, this Clausius-Clapeyron equation, you must be aware that this is nothing but, this is going to tell you the slope at any point from the horizontal. This angle was given by Clausius-Clapeyron equation. Getting my point? Are you getting my point? ये दिया था उसने, तो अब वो क्या करेगा, अब आपसे यही स्लोप पूछ लेगा, ट्रिपल पॉइंट डायग्राम का स्लोप बताओ. खेल गए, लाइफ बर्बाद. You have studied everything. You have studied everything. You have discussed everything, my dear. यू हैव रिकॉल ईच एंड एवरी फॉर्मूला, बट लाइफ यही बर्बाद हो गई क्योंकि आपने कुछ और याद किया था, आ कुछ और गया. आर यू गेटिंग माई पॉइंट? नो 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 नो, इट विल हैव सम वैल्यू. ओके, चलिए, ग्रेट. वो बाद में जब चेक करोगे, दैट इज द डिफरेंट थिंग. इट मे चेंज माय डियर. इट मे बी आस्क्ड फाइंड द स्लोप एट क्रिटिकल पॉइंट ऑल्सो. इट मे आस्क. So answer क्या आएगा? That will depend upon the numerical value. How HFG is given, how P set is given, T set is given. But until unless we are not aware with the reality, then definitely we are going to make the mistake. Just like this session यार, make 30. उसके बाद चलो आप कैसे सोने जा रहे हो, आ जाओ वापस. After that, let's start with the pure substance. Some properties of the pure substance is left. Critical pressure is known to us, 220.8 bar. Temperature is 374.14 bar. Sir, thermodynamic relation is also one of the important topic for this year. Thermodynamic relation question may be asked from the van der Waals equation. Van der Waals equation से पूरे आने के chances है question. Okay, after that, dryness fraction, mass of the liquid divided by mass of the liquid plus of the mass of the vapor. Sir, big mistake maximum of engineers have done in this case, or may do. Like sometime it is given that in this chamber, I will ask to all of you, yes, I am coming on the same point. Sir, Teju, sometime it is given in the question that in this chamber the liquid and vapor is filled in such a case that vapor is going to cover 50% of the volume and liquid is going to cover the 50% of the volume. Can you please tell me what is the dryness fraction? Any one of you? In this container, in top 50% of the portion vapor is given, in bottom 50% of portion liquid is given. Can you please tell me the answer? What is the numerical value of the dryness fraction? I just want to know it is less than 0.5, greater than 0.5, or it is exactly equal to 0.5. 0.5, less than 0.5, greater than 0.5, or equal to 0.5. What do you think? If the upper 50%, 0.5, very good, 0.5 Kenil, very good, 0.5 Parth, anyone else? Exactly what type of mistake you all are doing now? Examiner know very well that you are going to do this type of mistake. अरे वो जानता है आप यही गलती करोगे. My dear, in top 50% of volume, vapor is filled. Dryness fraction is not the ratio of friction or ratio of volume. Why you are not getting? Why you are not feeling? Are you getting my point? A dryness fraction is the ratio of mass, not volume. In most of the question, I have clearly seen that it is clearly given that volume is shared by each and every portion of vapor and liquid by 50%, and you write this portion as the 50% dryness fraction. फंस जाओगे. डिफरेंस करना सीखो आपने, क्योंकि फ्लूइड मैकेनिक्स में ये पढ़ा है जितना वॉल्यूम उतना मास, थर्मो में नहीं होता. Not getting my point? Are you getting my point? In this case, it is given that total volume of the liquid is equal to total volume of the vapor, or it can be written as specific volume of the liquid, and mass of the liquid will be equal to specific volume of the gas and mass of the gas, my dear. Why? How can you make this type of mistake? कितने लोगों ने सेम गलती की है और की है आपने एग्जाम में भी. That's why you are writing here, Teju. So in this case, when you check the specific volume of the liquid and gas now, then at that time you will get the ratio of the mass, then you will find the dryness fraction. Never ever make this type of mistake, my dear. Okay. Then, sir, you can't forget these 5 golden point of the pure substance, what exactly I'm going to give you. Like one, saturated liquid state, my dear. At saturated liquid state, what will be the value of S1? That is equal to SF at given pressure from steam table. Similarly, what is the value of H1? That is the value of HF at given pressure. You can't forget these important points. That is S4, my dear. Saturated vapor means this point. That will be equal to S4 Sg at given pressure. That will be also equal to H4 will be equal to Hg at given pressure. किसी को कहीं भी कोई डाउट आ रहा है, feel free to ask. These value can be given from the steam table. From the steam table. From the steam table. You are not going to make the simple mistake, my dear. No, only thermo will be completed today. In the next class, I am going to discuss the applied portion also. Enthalpy HF plus of HFG. And let me tell you, this HFG is also known as latent heat, my dear. After that, H in wet vapor can be written like SF plus of X HFG, and this will be equal to SF plus of X latent heat divided by T set. Similarly, if I'll ask what is the enthalpy at saturated state, that in superheated state it will be equal to Hg plus of Cp T superheated minus of T saturated at a given pressure, and S superheated will be equal to Sg plus of Cp ln T superheated divided by T set. सर मैं इसलिए जल्दी लिख रहा हूं ये कि मुझे इतना भरोसा है आप सबको ये आता है, क्या नहीं? ट्रस्ट ऑन यू. बोले नहीं, उसी में तो धोखा मिलता है. Thermo only we are going to cover today. In subcooled region, it will be equal to S of liquid minus of Cp ln T of saturated divided by T subcooled liquid. HL minus of Cp T of sat minus of T of subcooled. Means if the temperature of your mixture, what is exactly mix, if it is less than T saturated from the steam table, this will be checked from the steam table, then it will be the case of subcooled liquid, my dear. Subcooled liquid. Okay. After that, gives phase rule. Yes. Below the saturated temperature, you can say. Then behavior of the real gas. Sir, here I want to make one important difference in this case, my dear. One thing must be very clear. Sir, there are generally two formulas. दो फॉर्मूला हैं जो वंडर वॉल के हैं. एक तो ये फॉर्मूला है जो आप एज इट इज देख रहे हो. हियर माय डियर, द वैल्यू ऑफ द वॉल्यूम इज स्पेसिफिक वॉल्यूम, लाइक मीटर क्यूब पर केजी. मेक द डिफरेंस. एंड द वैल्यू ऑफ द आर, माय डियर, इज किलो जूल per kg Kelvin. Means specific gas constant. But from here, there is also one more van der Waals equation, that A divided by V bar square into V bar minus of B is equal to R bar T, my dear. Are you feeling some difference in all case? Sir, here B bar is molar specific volume, means meter cube per kilomole, my dear. Sorry. Yes, this one is given in molar volume, like this. And this R bar is given 8.314 kilojoule per kilomole Kelvin. Okay, per kilomole Kelvin. XC, in XC, question is asked. क्वेश्चन दिया था, मास एवरीथिंग इज गिवन. आप एक छोटी सी गलती कर दो, यू विल गेट द रॉन्ग आंसर. लिख लो कहीं, अगर लिख सको तो. हाईलाइट दिस पॉइंट माय डियर. इन van der Waals equation, units will play a very important role. Write somewhere. A and B unit, this, see, because this is the subtraction, this is also the subtraction, so B unit will decide the unit of V bar. Are you getting my point? B unit will decide the unit of V bar. Unit will play a very important role in real gas equation, my dear. Don't forget to apply this formula. Okay, so this is the real gas equation in both the condition. This I have written in molar form, my dear, and this is in the mass form, my dear. In both the form I have written the molar form. Yes, exactly. Kenil have written very important. Exactly. This is the unit of A, my dear. Okay. This what exactly you are writing. This is the unit of A, meter raised to 5 kg per second square. Good. Yes. Equivalent gas ratio in gas mixture. Sir, lot of gas are there. So in that case, R equivalent can be written by R1 plus of, sorry, M2 R2, M1 R1 plus of M3 R3 divided by M1 plus of M2 plus of M3. Similarly, Cp equivalent will be equal to M1 Cp1, M2 Cp2 plus of M3 Cp3 divided by M1 plus of M2 plus of M3. R equivalent. Sir, N value is given without converting the volume. We can directly put N value in the formula. N, are you talking about number of mole? N value, you are talking about the number of mole, if I am not wrong. Teju, is it? I am waiting for your answer. Yes, okay, no, you can't write. So generally formula is given, and in this formula you just need to, N will be given only to convert the volume either into the mass specific volume or into the molar specific volume. बस इसलिए दिया होता है N. Number of moles are given, so you will convert your volume into the molar volume, and number of or the mass is given, then you will be eligible to convert the value of volume into the mass specific volume. Clear to all? Is it clear? हाँ, मतलब या तो फिर आप पूरा फॉर्मूला कन्वर्ट करो फिर, but it will be better just molar or mass is given to convert the volume into specific volume. Either it will be molar, then you have to multiply by N, divide by N, and if it is the mass specific volume, you have to divide by M. You will divide the volume with M, my dear, because molar and mass both are affecting the volume only, because you know very well that this entire equation, my dear, is derived from here, from this ideal gas equation. This only equation is derived, my dear, and in this case this volume is change only if you will compare the ideal gas, because pressure is having the unit of kilopascal, R is having the same unit, T is having the same unit of Kelvin, only V is changing. So V may be the molar. When it will be molar, my dear, when it will be molar, then definitely in that condition it will be divided by number of mole. When it is the mass, it will be divided by the number of mass. Oh, sorry, kg of mass. Okay, yes. After that, this is the mass fraction. After that, sir, somewhere if the mass fraction is given, कई बार क्या होता है, percentage दिया होता है. What is that mass fraction? Let me tell you, my dear. In that condition, it will be directly given that like M1 divided by M1 plus of M2 plus of M3. In this way, this is given by P1 fraction, like this. In this way they are given. Getting my point? Like mass 1 is having the 80%, Kenil. Second is having the 20%. Then how or what will be the value of R equivalent, my dear? So in this case, you will write that P1 percentage of first one into R1, my dear, plus of P2 of the second percentage into R2, my dear. This will be the answer. So sometimes total mass is given, sometimes percentage of the mass is given. Getting my point? In this case, nothing is changing, Kenil. Only we have just converted the total mass single mass divided by total mass in the form of percentage. Bolo, clear hai ye? Kenil, is this point clear? So that's why sometimes fraction or the percentage is also given. So this is the ideal gas mixture. So in this case, my dear, we have discussed all the important formula related to this topic. I am going to share entire PDF in this session, my dear. We have taken 2 hours and near about 15 minutes to complete these all the formula. Utilization of the all formula is important. Where we can make the mistake, कहाँ हम mistake कर सकते हैं, exactly तेजू, कहाँ हम mistake कर सकते हैं, कैसे बच सकते हैं, these all point we have discussed in today's session. Don't stop unless you will not get your score in the GATE 23 exam, my dear. मिलते हैं फिर से. Just like the session, if you just enjoy the session, hopefully some mistake you can reduce from the session. I'll just share the entire PDF. Thank you all. See you again in the next session. Be energetic at least for next 1 week. Good night all of you. नींद अच्छी लेना, अब सो ही जाना. It will be better because in daytime, my dear, you have to work a lot. Yes. Sir, once how check specific volume is CP, please? Specific volume A. Not getting. Very good. Very good night. Very good night. Yes. Teju, you just share the session in share your comment in my Telegram channel or personal. I'm not getting your point. Don't worry. मुझे लिख देना. Okay. चलिए. Thank you all. Good night all. Okay. Teju, your point. A critical point, na? It is already given. For water, my dear, critical point is 0.003. It is fixed. Meter cube per kg. Because critical point is already fixed. Okay? Good night.